Okay, my chemical friends, you are going to love this. Everybody loves gold. Who doesn't love gold? Gold, gold, gold. Okay, so what is gold? It's in this particular group, group 11. Gold is AU. And copper starts this group 11. So what is the difference between copper and gold? Well, there's a slight price difference. Now, what are we talking about when we're talking about electrons and shells and orbitals and nucleuses and all that? Well, here's the deal. You have a atom, all right, and it has a core called a nucleus, and then you have a whole bunch of electrons, which are these in shells. So you only can have a little bit here, then a few more there, and then 18 more out here, and then 18, so forth. See, until you get to 32, and then it goes back to 18 again, and then 1. Well, how do these electrons get stuck out here? And you have to, the nucleus also has to be constructed where it can hold on to these electrons, and it reaches a resonance frequency where the electrons are so in harmony with the nucleus that they're not going to go away. They're stuck there. You cannot get them out of there. That's what the stable gold particles are. All right, atomic gold is quite stable. Now, how are we going to make gold? Can we force electrons to go into there? I think we might be able to. And what would we force them into? Copper. And how would we do that? Well, let's see if we can figure it out. Okay, this is brand new research, and it is research done through a Venturi with laser light. And what happens is the photons themselves are attached to positive and negative particles, are make a photon, and then back-to-back electrons, which are these particles here, make photons. Now, so what are we dealing with normally when we're working with electricity? We're pushing particles through that have two pieces to them. One's dark and one's explosive, the electron and then the dark particle. But they're attached, and they go through, and they stay attached together, but they move around through things, and they are electrical. Well, through the Venturi, they do not stay attached. What I'm saying is if we can make that electron, because what we're looking for is more electrons, if we can make that electron fuse into copper, it will possibly create gold. And here's what I say we could try. All right, I know it's crazy sounding, but I believe this is exactly what we created was muons and electron showers. They can call them muon neutrinos, electron neutrinos, call them anything you want. But they are normally attached together. That's the white particle, that's the black particle. The black I consider now to be dark energy, dark matter. It does absolutely nothing, has no impact, no value whatsoever. This is explosive as hell, and you're going to see it. But when they come through, they're attached together. That I call an electron. And back to back, one like this and one set the other way, is what I call a photon. Let's take a look. Now that's what I call a photon, and that's an electron here, and that's an electron here. Back to back, just like you put bar magnets together. These are the explosive portions. These are the dark matter. And dark matter does have only one attribute that I can find. It is attractive. It tries to be attached to the white. If the white is out of control, it gets out of the way. That's all I can tell you. Now, how did we make the whites get out of control? We could put them through a Venturi, and this is exactly what we did. We took the pulsed red laser and then fed it through a Venturi down here. To get through the Venturi, it has to suck everything through and accelerates everything. And when it does, it forces these particles to concuss into every other particle's regions. And these particles are not just that little particle that we saw here. That particle literally owns enormous regions around it of magnetic influence. Just like the magnets, if you push one against the other, you're going to feel out here, you don't see anything, but you're going to feel there's an influence. These also have these huge influences. When I force those to go together into that Venturi, they just don't like it. They just don't like it. And they just get crazy. And the black balls that were attached to them, which we see here, say, well, I'm out of here, I can't take this, I'm just going to walk away. And they just go right around here, and then something else, black balls, comes in here. I know they're not the same ones, go and finding the same white particles. So we know they're completely separate particles. You can't tell me that that black ball that went away here, we're going to look at it very closely, finds the same particle back here. It's literally impossible. All right, so my claim is you saw the light, it came into here, it separates here, and the black particles just get out of the way. They are not involved in this reaction at all, not a single one of them. They get out of the way, and they just skirt around the edges. And they just want to come back in, but they don't want to come in until these guys get back in control of themselves. They're just out of control. They're just way out of control. Now, the thing of this, look here. You see the blacks? Do you see these little black balls? They have really no issue being on top of each other, right next to each other. But you see the white normally surrounds them. You see, you can actually see that that's a whiter white surrounding that black dot. And that's a whiter white, whiter white, whiter white, white. And they're coming back in now. The whites are coming back in to surround the black particles at this point, and then at some point they become back into that photon shape which we saw before, that little box looking thing like that. That's what I'm seeing. Now I go by visual a lot, and this is, they want to see muons which do nothing, absolutely nothing whatsoever when they hit this Venturi. These explode into these electron showers. I'll show you those. They're very, very cute looking things. Now, why do I say maybe we can make gold? Let's say we had a thin film of copper. Like a roller coming around here with copper. And we are hitting this thing with, this is, to me, this is raw electrons. Absolutely raw electron. No muons there. No positive particles whatsoever. Just the negative portion of the electron. Electron really is a bipole, a dipole. All right, this is really what an electron is. They've always said, oh, it's just a negative. No, it is not. It's got both sides, and 1,837 of them are in a nucleus making a proton, which would be a hydrogen proton, let's say. But you just keep adding 1837 at a time, it makes more and more protons. Think about it that way. But they're always just constructed of electrons. And that makes everything work. 100% works now. 100% works. Photons, you saw them. You saw when they impacted, it did this. The black ones walked away from the white ones. And the yellow does exactly. The green does exactly the same thing. Any particle, any light photon, in my mind, all it is a spin. Let me show you what happens with light. These are those electron showers, and in my mind, this is electrons. That one's spinning backwards and created a particle which is neither light, is neither the electron or the muon. It's something very strange. All right, that's the particle it created when it popped into that, made that. Now that's a single slit. Light spins to the right. You see it? This is like a drill bit. And that's why it creates these repulsion patterns, not interference patterns. This is a single slit. This isn't a wave and a wave and a wave, double slit. And this is a big round pins, one on each side, forcing the Venturi, creating these electrons. And the electrons push the other electrons out of the way, and they end up creating these stripes. You see them? And every particle spins at a different speed. It depends on how fast it's being shot out of here. The red ones, let's say, are way like this, very slow spinners. All right, the green ones are somewhere down in here. The blue ones are way down in here. And then you get down in here, and then you get to a point where it's not electrons anymore. You're getting into chunks and particles, and they're bigger pieces. And they're much more destructive, obviously. And as you get faster and faster spin, the impact value is higher and higher. The smack, bam, If it's just coming slow and it bumps you, well, that's not a big deal. But if it's spinning a bazillion miles an hour, I don't care if it's how heavy it is, it's going to still cause some damage. Especially in the cellular range. That's how things get damaged. Too much energy smashes the particles that are in there. And then they explode into literally decay. And that's when you get physical bodily damage from radiation. Well, I just ran into this. I don't know if it has any real meaning, but they're talking about molecular surgery on a 23 gold atom nanoparticle. Now, they're trying to do something for some different purpose, but what I'm looking at here is they're talking about carbon and well, sulfur, gold, sulfur, then you got a silver, a sulfur, hold on, what is this, hold on. And it talks about how it breaks down, and it gets down towards copper. That's what I'm looking at, is getting into the copper range and then forcing atoms in and bringing it up to the gold range, possibly. I mean, I'm just absolutely guessing. And I really don't think there's any chance of it being possibly done, because you have to affect the core, or the nucleus, and it may be able to be done, but it would require quite a bit of energy, I believe. It wouldn't be like light. It would be almost, it would be so intense that it would have to accept the electrons. But it would have to be intense radiation. I mean, powerful, powerful, powerful blast of these electrons through a Venturi. So you'd have to start with extremely intense light, and it would have to be on, it wouldn't be the red laser, it would be as highest power laser you could get, and just blast the hell out of the copper. And it would have to be very, very close, because you only got nanometers to work with before they start to come back into with the dark matter and start to just turn into regular matter again. At that point, you can't fuse that in very easily. That can create heat, it can create all kinds of things, but it can't really create molecules and atoms that change, I don't think, a whole lot. It's called conservation of matter, where you burn something, it breaks it down, but it's still the same stuff in different pieces. It's even like this catalase breaks down hydrogen peroxide, which is H2O2, but you end up with H2O and then an extra O. And that's the way normally it works. However, coming through this Venturi, that changes the game as far as I'm concerned. There's a lot to look at here, and I can't look at it. Rod can't look at it. We don't have the resources and the means to do that. So I don't know if it has any meaning or not, but nobody will ever know. All right, if you want to make gold out of copper, here's what you have to do. Here's you got copper, silver, gold. All right, gold and it relates to the number of rings basically around the core. Now, not only do we have to add electrons to the rings, we have to force them into the core. If we force them into the core, they just automatically add to the rings. So how do we force them into the core? We could see that we had literally electronic soup. As far as I'm concerned, all we had was these. There was no chunks. All we had was electrons. Now, if we can somehow stimulate them with a frequency generator, a shaker, that resonates in the cavity that these things are, these electrons in that electron shower we created. If we can make that frequency occur that makes them stable, they might come out the other side gold. I have no idea. I'm just guessing. I mean, this is silly, to be perfectly honest with you. But people seem to love silly. All right, so here's the basic structure you got. Copper, you've got 2 in the first layer, 8, then 18, and then 1. Silver, 2, 8, 18, 18, and then 1. Gold, 2, 8, 18, 32, 18, and 1. So what do we have to do to turn copper into gold? We've got to force electrons down into the nucleus in that soup and resonated at such a frequency that it locks in at these numbers. And I'll show you how they lock in. Okay, this is one of my favorite people's Brus Pup. They got 16 million hits on this, about, I think maybe 12 million are mine. Now, as the pitch of the tone increases, we are going to see geometric patterns form and become more complex. I am saying that the salt they're putting on there is nothing more than electrons. And the electrons are being vibrated in the resonance frequency that forces them into a certain pattern. If we can induce a resonance frequency into that white plasma that I showed, who knows, maybe it could come out like it's coming out here. Watch. What he was just showing, you see these hertz? That means how many times it shakes in a second. Now watch, you see this? That is literally exactly what you would expect the pattern for hydrogen and helium. It only has a tiny little central core down here, the tiny 1 or 2 electron. Well, it's 1 or 4. Anyway, see, 1, 2, 3, 4. Now, this is the maximum you can have at this frequency. Now watch, when you go to the next one, we go into the rule of 8. But these are the particles, and as you shake the frequency, all of a sudden you're going to see the rule of 8 show up. And to me, that's the next line in a periodic chart. Now, and it just keeps going from there, up and up and up, until it gets extremely complicated way up in these. Look at that, see? Now, what we're up here is way up in this range. They're still starting out with the same particles. They're the same particles. At a certain frequency, they are hydrogen. At a certain frequency, they are gold. At a certain frequency, they're copper. If we can change the frequency from copper up to gold frequency, at the same time they are nothing but particles, I don't know. I'd like to see it tried.